Morning, everyone. My name is Sam McGee, and today I'm going to be presenting this respiratory protection refresher webinar hosted here by Chem Safety. I'm a senior occupational hygiene consultant, and I'll be your host today as we refresh what we need to know about our respiratory protection requirements. Now, this presentation is going to be recorded, and there will be an email sent out afterwards for all those that have registered to attend. And there is a bit of an interactive component. So if you have your cell phone handy, there'll be a QR code that comes up to answer some questions a bit later on. So today, in simple terms, we're going to cover respiratory protective equipment, or RPE, but in a bit more detail, we're going to cover why we need RPE in the first place, the types of RPE that are out there in the market, and the pros and the cons, and why we choose ones over the others, how to manage your RPE once you have it in place, and how things will change a bit in the future. So, why do we need RPE in the first place? We need to use RPE because there is a large range of respiratory hazards in the workplace. WorkSafe estimate that between 750 and 900 people die from work-related diseases every year. When you compare that to the road toll, or even those that die at work, it's a significantly larger number. And we look at this graph, you can see this is the total burden of harm estimates from WorkSafe. So catastrophic harm, that 0.13% that you see there, that tiny little red sliver, that is effectively your workplace fatalities. You know, there's 20 to 50 a year in New Zealand. Whereas if you look at all these other sections, cancer and respiratory, those will more than likely be caused by respiratory hazards. But, you know, respiratory hazards, solvents, etc., can cause things like hearing loss if they're ototoxic. They can definitely apply to mental ill health. Some can have psychotic effects. Some can weaken the bones in the body. So musculoskeletal disorders, they can add to that. So there's a large chunk of that overall burden of harm that can be attributed to respiratory hazards. So this is one of the interactive things we got today. I just want to have an idea of what type of hazards that you use your RPE for, or your workers use your RPE for. So you should be able to go to the website menti.com and use the code 8994-996, or alternatively scan that QR code, and you can put up to 3 different answers in terms of the type of hazards that you'll use your RPE for. So I'll give you a couple moments to let that work, and we'll see what the most common answers are. So we can already see some responses come through, and you'll find that the more common the response, the bolder that word cloud will be. So we'll just wait here as it updates. See some really common ones like asbestos and concrete dust. Things we definitely come across on a frequent basis. And we'll just see how this updates as people add to the picture. So as you can see already, a large range of different hazards we can use for respiratory protection. Obviously, we want to be adding other controls, and I touch on this more later, but respiratory protection is our last line of defense. So if this is our only control and it fails, we've been exposed to the thing. So we want to follow the principles of the hierarchy of control and eliminate, minimize engineering controls, etc. But that is a really good response from you guys. So we can see some really key things coming up. Asbestos, obviously, it's set in legislation that you have to use respiratory protection along with other controls, so it makes a lot of sense why that one would be coming through. General more general descriptions: chemicals, fumes, dust, welding fumes, biological. So we see these things here, and then if we look at some of the smaller ones, we get some more specific: bromide, formaldehyde, phosphine gas, solvent fumes, carcinogens, particulate smoke. So there's quite a range there. We're covering gases, vapors, particulates. So it is interesting to see the range of things that you guys have been exposed to, or that your workers are. So thank you for that. We now will probably get a secondary question come up on your phones. Let's start this one. So it's an agree/disagree with the statements. Feel free to skip it if you don't think it's relevant to you. But I do want to get a gauge of where you guys are at. So if you're unsure about everything RPE related, you'd call that question a 5. If you're very confident, a 1. If you use RPE and think you think you have everything in place, scoring up here at a 5. If you agree with that, if you disagree, down here. And if you have your respiratory protection program, which we'll talk about later, in place and have all the right hazards, then you'd be scoring 5. Whereas if you weren't so confident about that, you'd be scoring down here. So we'll just see where the audience is at. I'll give you guys a moment to answer that out. And we'll be doing this question again at the end to see how your perceptions may have changed. How many responses do we have? 44, 47. That's getting a good number. So it's good to see that, most of you guys are feeling okay, and we're getting a bit of a peak down here for this one. So you've got your RPE and you think everything's in place, and you're disagreeing a bit more about being unsure about RPE. So that means you've got a good level of knowledge. So that is awesome, and we'll be interested to see how that changes after the presentation. We will have some time for question and answers at the end, and we use the Q&A function within the webinar here. Awesome, thank you for that, guys. There's some couple of questions later on, but you can put your phones down a bit for now. So our respiratory hazards, they typically fall into 2 major categories in terms of how we can filter or protect from them. We've got gases and vapors, and we've got particulates. So gases and vapors, things like oxygen, it's not so much a hazard in itself, although too much is definitely hazardous. Too little is often something we have to be concerned about. And we can't filter out oxygen. So that's where the breathing air line or your self-contained breathing apparatus come in, which we'll talk about more. Some gases like carbon monoxide and carbon dioxide, not really things we can filter out particularly easy. So once again, we have to come to that clean air source. If we had an easy, simple carbon dioxide filter, we wouldn't be too concerned about global warming. We'd just be able to filter it out of the air. But things like ammonia, petrol, ethanol, hydrogen sulfide, swamp gas, if you've been around any rotten meat or sewage treatment places, you'll know the smell, rotten eggs of hydrogen sulfide. Methyl bromide, which we use for shipping, fumigation, so in shipping containers, etc. These are really common gas or vapor hazards that we'll come across on work sites. And in terms of particulates, they can be in many different forms. So we've got our dusts or our fibers like asbestos. They can also be fumes like welding fume or mist from certain aerosols. So if you've got like a aerated bath that you're using that can generate a mist, whether it be acid mist or something along those lines. So they can be technically liquid or solid particles in different sizes. Obviously, we all know asbestos and wood dust, potentially carcinogenic depending on the type of wood, but we all see carpenters, etc., covered in wood dust or carvers as well. Respirable crystalline silica from cutting concrete. You might know that the Ministry of Business, Innovation and Employment is currently got consultation out on what they could do in regarding engineered stone benchtops, mainly because of the respirable crystalline silica hazard that's out there. Flour dust, a substance that was recently under review for its exposure standard, and Ministry of Regulations had its own say on that. So if you've ever baked a cake or pizza, you know how easy flour dust spreads around. And even pathogens, certain pathogens can be filtered out by a particulate respirator. So COVID-19 was reasonably well filtered out by an N95 or P2 respirator. So there's a wide range of RPE types out there. So these are some of the common ones you'll find in New Zealand. So on the top left, we have a full face reusable respirator. Next to that, we've got a surgical mask, which isn't a respirator, but we'll go a bit more into that. We've got self-contained breathing apparatus next to that. And on the top right, we've got the airline respirator of a positive pressure in this case. Bottom left, we've got a powered air purifying respirator, or PAPR. Bottom central section, we've got a half-face reusable respirator. And then on the bottom right, we have a disposable half-face respirator. So when we're choosing our respiratory protection, and we'll go more into this later in the presentation, but just to give you an understanding to begin with, we've got a lot of things we need to consider to make sure we're choosing the right type of respirator for the job that we've got at hand. So one of the first things we need to consider is the hazard near or above the IDLH? Now, the IDLH is the immediately dangerous to life and health. It's not necessarily the limit that you will pass out after or die after one breath of that. It's more if you're exposed to that, you have 15 minutes to get out and don't come back until the situation is controlled. If based off our legislation and regulations, if we're at that, it limits the types of respirators that we can do. But also, how do you know what your concentration is? How do you know how close you are to the ideal age? Have you done monitoring? Do you have data loggers? These are all things that need to be considered. Also, what the oxygen concentration is. If we got these negative pressure respirators, which we'll go into more detail about, but our oxygen concentration is very low, they're not going to be suitable. Is the hazard or hazards in gas vapor forms, particulate forms, or both? Do we need combination filters? Do we need to consider other controls? These are things we need to add in. The concentration of the hazard has a huge effect. So filtering out something that's at 10 parts per million versus filtering out something that's at 250 parts per million is going to have a different shelf life on the filters and potentially deem some types of respirators better than others. The workload of the user. If I'm here sitting at the desk and I wear a half-face disposable respirator, I'm not doing too much. There's not a huge amount of respiratory load. It's all fine. I can probably do that for a long period of time. Versus using that same respirator while digging a hole outside, a trench. That's a lot more physical work. My respiratory rate has increased. The demands I'm placing on the respirator and on my body have increased. So these are all things that we have to take into account. And also how that respiratory protection fits with other PPE or required equipment. Is it going to interfere with my glasses? Or safety goggles? Or hard hat? Or everything else in between? We've got to make sure that our personal protective system synergizes with each other and they don't lead to issues and none of the pieces working as they should. So, in a bit more detail, we've got surgical masks, and they're not actually RPE. You might have, COVID did educate a lot of the people about various types of respiratory protection, and we did hear this being called respiratory protection, but it's not. They're designed to protect the wearer from airborne contaminants, gross splashes of droplets or bodily fluids. So basically, the blood or whatever else has been splashed isn't touching the face, it's not getting on the mouth or the nose, so it can be accidentally ingested or inhaled directly. It's really only to protect from those big splash type exposures, as opposed to if that same hazard was in a mist form or just suspended in the air, we will breathe it in through a surgical mask. It doesn't really filter. There's plenty of gaps for the air to get through and into our respiratory system. Then we have disposable half-face respirators. They come in many different shapes, sizes, models. I've got two here that you might be able to see. Doesn't matter if they're valves or not. If they meet the right standards, they will provide the protection. And as you can see, they're quite different shapes. This one's more of a cup shape, whereas this one's a bit more elongated. And there's many other models as well. So these are designed for short-term, one-off use. Basically, once this elastic is stretched, it doesn't provide the clamping force onto the face anymore, and it doesn't provide the protection that you required. And unfortunately, we see people reuse these frequently. So once it's been put onto your face, the elastic's been stretched, you've got a nice tight fit, and you take that off again, it's done. Goes in the bin. It's not designed to be used again. And unfortunately, we see lots of people, they've been used, they're hanging around the person's neck, or they've been used and they've only got one of the two straps on, the other strap is just hanging loose, or they're obviously filthy and have been used multiple times. None of these are providing anywhere near the level of protection that is designed to at that case. They're designed to protect from dust, fumes, and vapors, so your particulates. You might hear classifications of P1, P2, N95, N99, etc. We'll talk about those more later. And some models can protect from nuisance level organic vapors. They have a small layer of carbon, like charcoal carbon, inside the mask. But when we say nuisance level, we're talking about levels that are below the workplace exposure standards. So unless you've done monitoring or have data loggers and are able to understand what your levels are, they're probably not going to be the right sort of solution for gas or vapor type hazards. And they're what we call a negative pressure respirator. So that means we're creating a negative pressure zone. We're breathing in through the filter, and in this case, the filter material is the mask itself, and it's going to create an extra burden on the people who are wearing the respirators. But one of their pros is that they're very cheap compared to some of the other things, at least for the one-off use. And then we have a reusable half-face respirator. So I'll put one over here. These are designed for repeated use. They can protect from fumes, dust, fibers, gases, and vapors because you can interchange the filters. It does mean with maintenance that you need to have understanding of how long your filters are going to be in their service life for, which is quite different from particulates to gases and vapors. These interchangeable filters come out relatively easily and basically are treated as a consumable. So maybe it's after a month of use, you need to replace a new one. It all depends on your work case, so there's no hard and fast rules there. But with it being, reusable, you've got to then consider the wear and tear and make sure that it's not degrading or being damaged over time. Is it dirty? Is it filled with mold? I've seen some absolutely disgusting respirators on work sites that have just been left out there. All sorts of gunk and build up on the inside. Definitely something that respirator itself is basically becoming a health hazard. You might not be able to see, but there's orange valves on the inside of this one. Are they intact? Are they missing? When we do fit testing, the amount of times we'll see that it's missing valves or parts, or some of them don't even have these side bits attached anymore. They've just been taken off. So, they're getting no filtration whatsoever. These are all things to consider when choosing your type of respirator. They're a bit more expensive in terms of one-off costs than your disposable respirator, but obviously you can get much more uses out of these. Then we have reusable full face protection. So something along the lines of this respirator here. And compared to the half face respirator, it has very similar features in terms of interchangeable filters, but it also provides eye protection and a higher level of respiratory protection because it has a greater sealing surface. So the half face, as you can see, it really only just seals around the mouth and the nose, whereas the full face respirator, not only does it seal around the mouth or nose, but it has the sealing surface here, which goes around the edge of the face. And therefore it has sort of two layers of sealing protection along with the filtration as well. So it can provide a higher level of protection than a half face respirator reusable. So those are all negative pressure respirators, all negative pressure. So everything apart from the surgical mask needs to be fit tested. And we'll talk about fit testing frequency and why we need that later on. Our next respirator we have is a powered air purifying respirator, or PAPR for short. And this is another step up in terms of cost, but also another step up in terms of the level of protection that can be achieved. So it can either have a half face unit or full face unit. They can be tight fitting or loose fitting. Now this one here is a loose fitting. So it means that people with beards can use them because a tight fit around the face is not how the protection is achieved. It is achieved through filtering air through this backpack unit, which is then blown through a fan, through into the head, and you get positive pressure. So if there was a leak, the pressure is moving out past your face and the contaminants don't have the ability to get in. Obviously, some drawbacks are the cost. There's more parts, so there's more things that can break down. So maintenance is a key thing. And it's powered, so you need to consider battery life, battery replacement, charging, those sort of things. The next one, and I don't have an example here with me today, is an airline or self-contained breathing apparatus. These don't have to filter the air. They can bring the air in from an independent source, whether that be a tank or a compressor with an airline situated away from the contaminated zone. And because they don't need to filter the air, it can be a more tight seal around the face because they don't need a passive way for the air to come through. The air needs to meet set requirements in terms of its quality. So it needs to have no oil mist below a certain threshold, carbon monoxide and carbon dioxide below certain thresholds. So it needs to be within certain temperature and humidity ranges and water vapor, no other odors or other contaminants in it. So it's got to meet those sort of things. So we know we've got this clear independent source of air. It probably offers the highest levels of protection from those contaminants. Obviously, that's what your firefighters will use most times when they're entering a very hazardous situation. But it does come in with other limitations. So the training, the extra weight, if you've carried one of those tanks around, they're not light. ergonomic issues. So if you're trying to crawl up and down ship holds, for example, a tank may not be the right piece of equipment, as it makes it too hard to get in and out for access, or you're restricted with the area that you can work because of the compressed air line attached to it. Also, things with compressed air, how do you test that your air is of the right sort of quality as well? Okay, now with any respiratory protection system, by system I mean respirator, there are two parts, the mask and the filter. And the system is only going to be as effective as the weakest link. So if I have a filter that's damaged or lower grade versus the mask, then I'm only going to get the protection of the lowest level, even if in theory this mask could provide P2 level protection. If it's only got a P1 filter, it's only giving P1. And this, in the current New Zealand Australian system, a half-face respirator can only provide a max of P2. So even if I put a P3 level filter on, I'm not getting P3 level protection. I'm only getting P2 level protection. So we've got to consider the whole part with the masks. So there are different classification systems for filters internationally. We've got a system in Australia and New Zealand. There's an American system, there's a European system, there's a Chinese system, there's actually many more as well, but those are the main ones you'll come across in products in New Zealand. So during COVID-19, you might have heard a lot about N95 respirators. Well, that's actually coming from the American system. So N95 is equivalent to our P2 system, or P2 classification. The European equivalent of that is FFP2, and the Chinese equivalent is KN95. And there was a lot of confusion about what's the difference between a KN95 and an N95 or FFP2 versus P2. They're all more or less the same. There are some slight differences, but they provide generally the same level of respiratory protection. In Australia and New Zealand, we also have a colour coding system used for our respiratory filters. So P filters are white. You can see the white label here on this particular filter. And they can come in three classes, P1, P2, or P3. So P1 is for mechanically generated dusts or fibers. So think if you're using a bandsaw on a piece of timber, that's the mechanical generation of the dust when you cut the timber. So P1 filter could be suitable. P2 is for thermally generated dusts, although the asbestos regs do state that P2 is the minimum for them. So you could think of like welding fume would be a thermally generated dust or fume or fiber. And P3 is for highly toxic or highly irritant compounds. So beryllium is an example of that. You'll quite often find that most filters in New Zealand are sold as P2/P3 combination filters. So they technically meet both levels. We also have a color coding system. So white is particulate. And then you might be able to see here, this is a multi-gas. You can see there's brown, yellow, white, brown, grey, yellow, and green stripes in that filter. So that's a multi-gas filter, which covers a lot of the things I'm about to talk about. So the organic gases and vapors are what the brown or A classification is for, and that's for boiling points greater than 65 degrees Celsius. So common solvents you might come across like that are toluene and xylene. That's what an A filter would do. AX is for your highly volatile organic solvents with boiling points of less than 65 degrees Celsius. Things like methanol or dichloromethane are suitable for AX. Now, you can have AX1 or AX2, A1, A2. When we get A1 is the normal sort of thickness, and A2 is just more charcoal in it. So it's like a thicker version of the same filter, which has a greater capacity to hold more contaminant. B is for acid-based gases. Think of things like hydrogen sulfide, which is what you smell in Rotorua with the thermal vents, hydrogen chloride as well. E is for your inorganic gases, so something like sulfur dioxide. K is ammonia and its ammonia derivatives. And Hg is for mercury. If you remember from high school chemistry on the periodic table, mercury's symbol is Hg. So that's for mercury compounds. There are a couple others that are less common that you'll find, like NO for oxides of nitrogen and MB for methyl bromide, but they're not as prevalent out there. in the market. So what do we need to do when we have RPE? The simple answer is we have to manage it as part of a respiratory protection program, or RPP. Forgive me, there are quite a few acronyms in this presentation. So RPE, Respiratory Protective Equipment, RPP, Respiratory Protective Program. And we can look to the Australian New Zealand standards for how to do this, how to run our RPP. So the ASNZ 1715-2009 standard, the selection, use, and maintenance of respiratory protective equipment, is a section about your RPP. And we'll go into some parts of this in much more detail shortly. The RPP, when you use RPE per the standard, a respiratory protection program shall be established. It needs to have a person who's going to run that program. It's going to have a process for selecting your RPE, medical screening. So all these negative pressure respirators, whether it's a half-face respirator, like these ones here, or even the disposable ones, they put a lot of burden on the respiratory system because you're having to breathe through those filters. It gets a lot harder to do that. So people with asthma, COPD, or other cardiovascular issues might find that they're not suitable to be wearing these for prolonged periods of time, hence the medical screening. They might find that they've had to move away from that role or use something like the powered air purifying respirator with that fan, because that doesn't put the same demand on the respiratory system. Other things they might consider medical screening are things like claustrophobia. Some people will freak out wearing some of these types of respiratory protection. Training is really important as well. So training the people how to use it, how to maintain it, how to care for it. The issuing of the RPE, so what the process is for that, how you're going to fit that equipment, so fit testing, what processes you require the RPE to be used for, which ones are optional, which ones are mandatory, how to maintain that RPE, how to dispose of broken or used equipment, record keeping, and program evaluation. So we'll go through these 5 key aspects in a bit more detail now. Program admin, selection, training, fit testing, and maintenance. So for your respiratory protection program, there needs to be someone who's going to run it, and they need to have a background to enable decision-making on those workplace hazards. So why do they need it? What the difference in the exposure agents are. And you'll find that in industry, it's not always just the one thing. I'm not just exposed to asbestos. It could be, if you're in an asbestos removal enclosure, you've got the asbestos fibers, you've also got the other dust and fibers there. But quite often they could be using a solvent-based thinner to remove the resin to help scrape up the adhesive, on the floor environment. So now they've got not only particular hazards, but solvent vapor hazards as well. So there is definitely often more than one hazard that we've got to figure out what the best combination is. So in a large company, you're probably wanting the health and safety professional, whether it's a safety engineer, occupational hygienist like myself, an occupational physician, to help come up and run this program with you. In a small company, it might just have to be the employer or the supervisor, foreman there. You don't really want to leave it up to just the workers picking what they think they need, as they might not always consider all the factors that you have to in this case. So as we've talked about earlier with selection, there's lots of factors we need to consider. Does the respiratory protective equipment conform to the Australian New Zealand standards, in this case 1716? So you might remember during COVID, there was a lot of respirators come flooding into the country, fake respirators, pretending to meet standards or meeting international standards, and because there was such demand for them, they were able to get large quantities in and sold. What is the contaminant, and can we filter it out? How much of it is present? These are all things that will matter. How does the operator work? Other PPE, vision, or communication requirements. If I was to chuck this mask on my face and talk to you guys, you probably can't hear me very well now. So if my role needs clear communication, we might need to grab certain respirators that have a speech diaphragm that allows for clear communication. I've seen other respirator systems that have a microphone and a speaker style attachment. All depends on the nature of the job. What environment the operator is working in. Is it too hot, too cold? In a hot environment, something like the powered air purifying respirator, you might find is more suitable. I've been to a lot of sites with welders. They're generally resistant to going change into these, but then once they have them, they find them much more beneficial because of the cool, not only the protection, they're not breathing in the fumes all day, but the cooling nature of having that air blowing past your face all day when some of their work is quite hot. Low oxygen environments are going to limit which types of RPE we can choose. What types do we have access to is going to play a factor as well. And what type of cartridge or filter does it need? Is it a dust particulate filter? Is it a solvent filter? Is it both? You can get a combination filters that will do both. What's the replacement schedule? Sometimes for dust, it's easy. You just have a set time-based one. For solvents, there's a lot of factors: temperature, humidity, work rate, solvent itself, the capacity of the filter to bind that particular solvent. Some of the manufacturers have websites so you can put this all into and work it out. Others, you're just going to have to make educated guesses based off breakthrough times. At any point, if you smell anything through the solvent-based filter, it should be replaced. That's a key giveaway, but you ideally want to stop. If you're smelling it, you've been exposed to it, so you want to stop that before that happens. There was a job I did a few years ago where we had to work this out. They used a solvent, they decanted it in one room. The decanting process from the drum to the vessel that they used it in took about 10 minutes. This was a highly volatile solvent, so we're talking about those AX filter cartridges you mentioned earlier. They cost a couple $100 a pop. They were having to use a brand new one every day for the 10-minute period that they used it. So once per day, they'd decant this solvent for what they needed. And each day they had to use a brand new set of filters because that was how much capacity this filter had to hold that level of solvent. Often they can last a bit longer. Another thing with solvent filters, they have a shelf life. So on the packaging, there will be, once open, this will last for a maximum of this time. Quite often you'll find that your exposure means it lasts less than that, but you should write on them the date that it was open so you know which date at the very max that it has to be chucked out and replaced. So there's also a lot of factors that you might see in regards to respiratory protection program. We're not going to go into huge detail on them today. We've got the assigned protection factor, and that's given by the manufacturer. So that might be, this can provide up to 10 times protection from the outdoor atmosphere. That's APF. We've also got the minimum protection factor, or MPF, and that is what is needed to provide adequate protection in your workplace, in your situation. So the minimum protection factor is determined by having your airborne concentration and dividing by the exposure standard. So if we had a situation that was a really dusty environment and we had an inhalable dust concentration of 100 milligrams per meter cubed, our workplace exposure standard here in New Zealand for particulate not otherwise classified, otherwise known as inhalable dust, is 10. So 100 milligrams per meter cubed divided by 10 milligrams per meter cubed, that would mean our MPF would be 10. Which would typically mean something like a disposable respirator or a half-face respirator would be suitable level of protection. Now, a fit factor is achieved during the respirator fit test, and it should be 10 times the minimum protection factor, because when we do a fit test, it's a very controlled environment. It's only for a short period of time. We all know in real life conditions, that person might not be as clean shaven. They could be sweating. Could be, their 4th hour wearing it and their face is just starting to swell or change shape. So we want to put in a large safety factor when we do this test to make sure that they're getting the level of protection that they require in more real life practical situations. So fit testing, there are lots of reasons why fit testing is required. Some respirators come in different sizes. So this one here is a small medium. You can get medium large and large, extra large. There's lots of different sizes, but there's no guarantee that even with those sizes, that particular respirator will fit your particular face shape. I used the same type of respirator for 4 or 5 years, same size, was with one manufacturer. Then I did my yearly fit test and I couldn't get a pass anymore on this. It would pass its daily fit checks, which are the positive pressure and negative pressure checks you do every time you put on the respirator. But when I came for my yearly fit test, it wasn't fitting anymore. We tried the same make and model of respirator, just changed the size. That didn't work either, so I ended up with the same manufacturer but a different model. back to my original medium size, and that started fitting. So I'm not sure what changed in my face shape that year. It was unfortunately probably putting on some kgs. But that led to me having to change a respirator and proving why these fit tests are really useful and why they need to be repeated. And there's no one size, even the masks that come in one size fits all. It's designed for most face shapes. So when they do the manufacturing, there's a panel of different face shapes and they test it all and they try to determine, but there's no guarantee that your particular face will fit that particular respirator. And as I think I mentioned earlier when we're doing the word cloud exercise, respiratory protection equipment is often the first control measure, and it's that last line of defense. So if this fails, I'm now breathing in the thing I'm trying to protect myself against. So I want to have those other controls, and I want to make sure that this control is less likely to fail because it provides a good fit for me. And obviously, we have our legal obligations to protect workers from harm. So you can see in this picture here, there's a human here, 40 to 120 micrometers in diameter. The particulates we're often filtering from are less than 10 micrometers in diameter. So if there's any hair between the face and the respirator, there's huge gaps for this any of the respiratory hazards to come in and be breathed in. And of course, they're going to take the easiest path. Why would you go through a difficult filter matrix when you can just go through the gaps and be breathed in that way? So around the COVID time, WorkSafe put out their Life Shavers campaign here, which has a variety of facial hairstyles that are suitable for those that wear tight fitting respirators. Even on Saturday, I still had a full beard. I had to do some relatively urgent work over the weekend, and therefore I had to shave, be fit tested, make sure I was clean shaven and ready to deal with the hazards on site. And as much as people like to have their beards, if you're wearing a tight fitted respirator, it's not going to be suitable. So these are often compromise options because they're loose fitting. Although they're a lot more expensive, the person doesn't have to shave in that instance, but they're not necessarily suitable for all hazards either. So when you get a chance, have a look at these posters. They're all up on WorkSafe's website. There's some quite interesting names they've decided to call some of the facial hairstyles. So with fit testing, there are two different types. We've got qualitative and quantitative fit testing. Both types of fit testing will do half-face respirators and disposable respirators. But once you're getting to full face or beyond, then we need to be talking about the quantitative only. So qualitative fit testing involves getting the person to wear this lovely hood and spraying in a bitter or sweet tasting compound, getting them to do a series of movements, head movements, talking and breathing and body movement exercises to determine whether or not they can taste the agent. It takes about just under 10 minutes of testing by the time you go through the whole process, so it's quite long. And if they can taste it, then the test fails and we need to find a different type of respirator. It is a lot cheaper of a setup, but also the results can be faked. If someone's a pretty decent actor or got good control, composure, they can pretend they're not tasting it. And obviously we have no way to verify if they're tasting it or not. Now these Bittrex and the saccharin sweet solution, they do, to me, taste horrible. So it's quite hard for people to fake it, but apparently it has been done in the past. The other thing we have to consider is some people can't taste these things. If heavy smokers often really struggle to taste the bitter taste agent, hence why we have the sweet option, and there are some people that can't taste both. Obviously, you got some disposable parts with your bitter and sweet solutions, and got to make sure the system is hygienic between people, particularly in times like COVID. Our other system is our quantitative system. So we use a machine like the port account. There are some other options available. And what it does, I don't know if you can see here, there's some tubing attached to my machine, and it measures the concentration of particles inside and outside of the respirator to give us a protection factor. It requires power and certain conditions in the room in terms of particle concentration, so the size of the room or the nature of the area can have a part. It is more accurate. It does need adapters for your more permanent respirators, and disposable respirators can also be fit tested, but you need to put a little hole punchy type adapter in there, so they're not going to be suitable for use afterwards. And then you can just attach that probe onto your tubing and go from there. Now these fit tests, depending on the protocol you use, can be a bit quicker. So if you do have a large number of people to fit test, you can get through them a bit faster with the quantitative fit testing methods. So fit testing frequency, it's required at a minimum of once per year for each different type of respirator to use. So just because you've been fit tested on one respirator, but you've got 5 different options you have to wear, that doesn't mean you can use all 5. That one fit test counts for all 5 types. Fit testing should be done before you issue the respirator, and it should also be done when your facial characteristics change. So body weight plus or minus 10%. So for me, that's quite a bit of kgs now. But if you're a bit lighter, not a huge amount of body weight for fit testing should be done. Dental surgery, if you lose your wisdom teeth or braces or something like that, that could potentially change the shape of your jaw or face, then yeah, refit testing. Injuries, if you've got a broken nose, once that nose is healed, it's going to potentially be a different shape, hence the need for another fit test. Glasses as well, just how the glasses sit on top of the respirator can slightly change how it fits on your face. So once again, another reason to go through more fit testing. So we're going to do one of those poll type questions now again. Let me start that up. I'm quite curious as to when your last fit test was. I can probably display the QR code too, if that is. Yeah, we'll give you a moment or two to answer all that here. So for me, it was Saturday. So within the last 12 months, I'm glad to see some people there. We found in-house there was a huge demand for fit testing in the COVID times, 2020 to 2021. And you'd be amazed as to just how that all dropped off once that sort of overall pandemic push disappeared. So I'm not surprised there's a few that haven't been fit tested. Hopefully it's because you don't need RPE. But if you do, strongly recommend going and getting some fit testing done. Good to see a good chunk here within the last 12 months. So that is awesome. It isn't surprising when we go to sites to do exposure monitoring that we ask, when were you guys fit tested? And they say, the guy showed us when we get in, and we do the positive pressure, negative pressure thing, and that's actually a fit check. So every time you put on a negative pressure respirator, there's a fit check where you close the inlet, cover the inlet valves with your hands and breathe in, and you should get like a vacuum feel around your face. You should also block the exhalation valve, breathe out. You should feel the sort of pressure build up eventually before it bursts out. So those are fit checks, and some people do consider that fit testing. It's simply not. But those are done every time you put on a respirator. That should be done. So quite an interesting thread. So good chunk of you have been done in the last year, 12 months. That's awesome. Good chunk of you haven't been done, and there's a proportion here as well that have been, are overdue for a fit test if they're still using their respirator. Thank you for that, guys. I've got one more question. I think it's in a few slides' time. So PCBU, respiratory protection equipment duties. So there is a few different duties on us in our Act and legislation. We've got a duty to not levy or charge workers for RPE or for PPE in general. So yeah, we can't be charging them if their job requires, high level powered air purifying protection. We're talking potentially in the thousands. If your risk assessment you've done and this is the level of protection that you require, you can't charge the workers for that, even if it is expensive. Now, you might be able to charge them or help them if they're choosing to go above and beyond, like your risk assessment says, yes, P2 half face is totally suitable to protect them from what they need along with the other controls, and they're like, I would rather do this, can you help me? And they go, code payment or something like that, or they choose to fully volunteer and bring their above and beyond PPE, that's fine. But otherwise, you can't charge them for their respiratory or any sort of personal protective equipment. You need to provide that RPE to those carrying out the work in those hazardous environments, and that RPE must be suitable for the work. So that means it's got to be fit tested, sorry. It's got to fit the work. It's got to be not causing them pain, discomfort, all those sort of things. It's got to be in working order. The RPE must be clean and hygienic and in good working order. So there's no point giving them someone's old respirator. It's a bit gunky, moldy, filters a bit cracked or damaged, missing seals. That's not useful. But this is also part of the duty on the worker itself. You've got to give the workers the information, training on how to wear, store, and use and maintain the respirators. The amount of sites I see respirators just hanging up on the workshop wall, they're coated in the fume that's built up in the workshop. They've sort of dried out and cracked. Ideally, some respirators will come in their own container. If not, you can just go and buy, your standard steel, plastic lunchbox style container, Sistema or whatever brand you want, and those will work sufficiently as well. There, same time. I should have posted a more shame of some various respirators I've seen on sites. They really are quite manky. Definitely not things they basically become hazards themselves. You're breathing in through them. So future changes. Now these are starting to go live, and just last couple of days they've announced sort of a webinar next month from the standards committee about what's going to happen with these standards. So I suggest go and check that out as well. So over the last multiple years, the International Standards Organization, ISO, developed some new respiratory protection standards worldwide. They sort of overhauled it all. And New Zealand and Australia have been the first countries to adopt those ISO standards as their new respiratory protection standards. So these were made live, they were sort of adopted and made live within the standards framework last year. But our current standards are still live, the 1716 and the 1715. There will be a process to sunset them out. It'll have like a 3 to 5 year time window, but that clock hasn't started just yet. Because we're the first country to do that, adopt these international new standards, there are not many respirators designed or tested to meet these new standards. So we've got to give the market time to produce these respirators and testing equipment and go through from there. One of the big differences between this old standard and the new standard is it's going to be performance-based. In our current standard, what level of protection you get is defined by the type of respirator and the type of filter. So a half-face respirator, reusable respirator, will only give a max of P2 level protection in our current standard, and a full-face one, providing it has P3 filters, will give you P3 level protection. If it has P2, it goes down to P2, etc. Under the proposed new standards, there'll be performance-based criteria. So each mask we test on its own merits, and it could be that this one meets the equivalent of a P3 level thing because it's got really great seal or something along those lines here. And even though it's a half face, it still meets this equivalent of P3 level protection. So it will lead to a bit of confusion, or if there are some types that go above and beyond what is standard for that type there. But there will be a long period for the manufacturers and respiratory sales equipment places in New Zealand to move to these new areas. So we've got our final question here. And I'm just curious to see if there's any change in your opinion about your respiratory protection equipment. Are you more sure after seeing some things, like actually I know more than what I thought I knew, or are you feeling a little more uncertain? I'd be very curious to see what the results are between that. So I'll give you guys a moment to answer again. And you can skip questions that you feel aren't relevant for you or your particular setup. We will have a question and answers section a little bit shortly on, so feel free to post some questions in the chat as well. Okay, we're starting to get some responses. It looks at this stage that some people are a bit more unsure, so perhaps I've given you guys some new information, but I'm also seeing some people that do look a bit more confident as well, so that is good news. In the presentation at the end, I'll take screenshots of the final results of these two polls. Actually, I think you guys can see it on your apps too, where what the difference is between the starting and post there. That is awesome. Thank you, guys. So we can see here there's sort of two peaks. There's a group of people that are feeling not particularly sure anymore, and a group of people that, there's a group of people that are feeling more sure, so that is good. And there's a group of people here that are a little bit unsure, but I think that number is less than previous. So that is good to see. There's actually quite a broad spread here of, I think they have everything in place, and that's good to see. So we, these people are reasonably confident, and we tail off to being a little bit less confident. And in terms of a respiratory protection program and have the right PPE for the right hazards, quite flat. There's over those that are really confident, the group that are unsure in the middle, and then there's a small group of not particularly sure at all. So that is awesome. So, but what can happen next? So at Chem Safety, we can help people with their respiratory protection issues or their just workplace health hazard issues. We can help you find suitable respirators, do fit testing, develop fit testing programs, develop your respiratory protection program, all that stuff we can help you. We can obviously help with your initial risk assessment in terms of your hazards as well. Some more information can be found at WorkSafe's website, the NZOHS, New Zealand Occupational Hygiene Society, so I'm one of the members of that. They've got some great respiratory protection information. Commit to Fit is the program that NZOHS run, and that is for people to go through a program to make sure they're the right, they know what they're doing with fit testing. So there are definitely other ways to prove that you're a competent fit tester, but one of the easiest ways is Commit to Fit, and we have plenty of Commit to Fit testers here at ChemSafe. PPE companies are a great source for information on their filters, their respirators, their cartridge life, things as well. So 3M, Moldex, Shigematsu, Sunstrom are just some of the brands I've used here today. And I must say thank you for 3M for letting me borrow their paper for today. Australia and New Zealand standards, you can always check the old ones out. They're still in force, and at the moment, since we don't have respiratory protection of equipment that is designed for the new standards, probably your go-to, so 1715 and 1716. They do cost though. All right. Now we have some time for some questions, and I see a few questions have gone through. Let's see what we've got here. What brand of masks am I holding? This was a Moldex half-face mask. One of these ones here. This one was a 3M Aura, which is one of these ones here. This was a Sunstrom half-face respirator. A Shigematsu full-face respirator. And a Powered Air, 3M Powered Air purifying respirator. So I've got another question here. Where work is periodic, e.g. a worker may only be exposed to 2 hours in a workday in a dusty environment. Arranging fit testing is not practical. Is negative positive pressure test sufficient where the exposure to the material is not highly toxic? So with the standard, if you're having to wear a respirator, you would need to get fit tested just once a year or when those situation changes. So those fit checks every time they use it, that's great. But once a year, they don't have to be exposed to the agent when they're getting fit tested. They can either be fit tested by the particles and their fit particle concentration within a fit testing machine, or with the bitter sweet solution in the qualitative one. I've got a question here. Do you have a link to cartridge filter selection poster that we can refer to and use, please? We'll be able to put something up with the resources that come out after the webinar. There's plenty of information, and obviously things do change slightly from manufacturer, so we can put out something in general, but also check with the manufacturer of your particular PPE system. template of respiratory protection program. So you can always go to the standard and cover those things. We do have our own one that we can put out for you guys, but we won't put that out as a free template. It's something that we've worked hard to develop for the clients. So we've had people that are very happy with using that respiratory protection program template, and they've managed to some were case of improvement notices, and they've managed to meet the requirements that WorkSafe have put on them. Others are just of their own volition, and they've been happy with the results of that program. But all that information is available in the standard if you wish to go that way. Interested as to what ocular protection to substances a half mask will provide over a full face when new RPE standards come out, as not all chemical goggles fit well. Yes, now, to be perfectly honest, I have not read in detail all 20 of the new standards that are coming out, as they're not quite live yet. Having the combination of your goggles that fit gases, vapors versus your half-face mask is very difficult, and not all combinations work. You might find that the one mask that fits that particular worker doesn't fit when they have to wear the goggles that they work. So if there are specified PPE that they need to wear, they should be wearing that during the fit testing process, so we can make sure that we cover it. Yes, I haven't read the one about the eye protection sub part of the respiratory protection, so I can't help you more there at the moment, but I will do some looking into it. What kind of dust was P2 for? So P2 is thermally generated dust. So any dust or fume that's generated from a combustion type process, so a fire or a welding type thing, is typically what we're talking for P2. Other things like asbestos have in legislation that P2 is the minimum required. For the person that missed the start of the webinar, there will be a recording that will be sent out to you guys afterwards, and feel free to share it with whoever you like. Our organisation has gone for all loose-fitting PAPR approach to mitigate fit testing, but still continue with education and training on proper usage and hazards. I often question if this is an acceptable approach. That's without knowing the specifics of your hazards. There are quite a few companies that go to loose-fitting PAPR solution for dealing with the facial hair issue. A lot of men are unwilling to shave. That's actually something worth bringing up. So particularly Sikh men, there was a thing called the sling flatter. I might be mispronouncing that technique. During COVID, where they tried to get fit tested with a rubber, like one of those exercise bands put over their beard, and then fit tested onto that. That's not something that even in Australia and New Zealand's fit testing committees, it's not acceptable. We have to test the thing to the surface of the skin. So facial hair or anything like else in between is not appropriate. So there does get to be some difficult grounds with the religious side of things with some facial hair. But going to powered air purifying, it would be unlikely in most workplaces that you'd be at hazard levels where that wouldn't be suitable. The things that you would need to consider are decontamination sort of aspects. So asbestos isn't necessarily the best with powered air loose-fitting respirators, because the asbestos fibers can get trapped in that material, and it's very hard to decontaminate them. But in most other situations, you should be fine. And feel free to email me more specifically about your personal situation, and I can help with that. We're not lawyers. We don't charge immediately after picking up the phone or writing an email. There's a question about the sling flatter. So it's not something that personally I approve of as a suitable technique. I understand the difficulties that these people face with that, and it is a bit of a difficult zone, but I would never fit test someone who was trying to bring that out as an option. I would recommend they would have to move to some other sort of control where they don't need to wear PPE in the first place, or that higher order control where they don't need fit testing. If the workforce refuses to clean shave, is the company compelled to provide PAPR air-driven masks? Not necessarily. I wish I could find the case law again. I believe it's in Australia who has very similar legislative setup to us. There was a case in Tasmania, and I should have actually brought that up, where they, for non-religious grounds, they just didn't want to shave their beard. It was deemed not suitable as enough of a reason, and they, after going through the courts, they were compelled that they did have to shave their beds for protection for safety in that case. I'm not a lawyer or anything like that, so I can't say how definitively relevant it is to New Zealand, but that could be something to look into. You can always look at those other controls. So is the work, can you control it in another way without PPE? I know that some people within the regulators have the opinion that there's the bit of the health and safety law that you to comply with all reasonable instructions in regards to health and safety. So is it a reasonable instruction to shave? That's probably up for the courts eventually to decide. The other aspect is that you can add something into the contract at the start of the process. So if they're contractually obliged to, then you've got some ground, but obviously that doesn't work for pre-existing workers. If we are holding PPE for in case of spills, do we still need fit testing? It depends on the type of RPE. So there's some things called emergency respiratory protection. So they're designed for like single-use escape. Typically, you'll see them in factories or ships or something like that. That wouldn't need to because it's typically a positive pressure type thing. But if you were holding something, things like this or this as your spill kit, ideally, yes, you should, because they've been issued to a person or issued to a person in general. They should be fit tested. Obviously, if it's not for a specific person in general, it's better for them to be wearing PPE than nothing at all. But if it is at all reasonably practical to fit test, then I would be recommending fit testing. Are any full face respirators made for glasses wearers, I'm assuming, and are some made for those with beards? There are no full face tight fitting respirators made for those with beards. Some manufacturers do offer the ability for a little like old school reading glasses that can sit inside the mask with prescription lenses. I've heard they're horrifically expensive, but they are possibly out there. I haven't seen one in practice though. Is category A suitable for protection against isocyanate? It would definitely be the type of filter I'd lean to, but you'd have to look into the particular isocyanate and its boiling point, along with some other things. There, if you can go to airline, that's great. Sorry, not airline, like PAPA or higher order, because isocyanates have that sensitization. But without knowing the exact isocyanates, because there's a huge range of them, it's hard to say. But feel free to email me and I can do some looking in there for you. Any cartridge filter good for both particles and fume? Yeah, so you can get combination ones similar to these, except they'll have a particular style bit attached on front too. So you have your particulate filter and then you'll have your solvent type filters going in and behind that. This one, WorkSafe is recommending annual fit testing. However, it is not compulsory. Can my organization only do an initial mask fit testing and fit test where there's a change in a respirator and or facial weight change? So it isn't set out in law specifically, but your PPE has to be suitable and fit for purpose. That's often what we'll see the improvement notices written by WorkSafe on. They will go to the standards as best practice. It would be a high burden, a high bar for you to prove that your system was equivalent to or above if it ever went to court or something like that. That testing initially and when something changes would be, yeah, you would have to have quite a big lengthy thing to document why that was possible. I would say it probably wouldn't be. So they refer to the standards where they can, and yeah, being fit for purpose is their main thing they go for with the respiratory protection. So how do you know it's fit for purpose? You go fit test it, and the fit testing is per the standards required at those sort of intervals. Do the multi-gas cartridges have the same protection as a single gas for chlorine? Bad answer, but it depends. It would depend on the nature of that specific filter. So if you are off one specific manufacturer and you go to their calculator on their website, they'll probably tell you which one's the best. if something is specific for a single gas, it's normally going to have something else treated to the carbon in there to make it more preferential to bind and trap that product. So it's probably more likely to be effective for chlorine in the single gas than in the multi-gas. But if you've got other hazards as well, then you might need to lessen your chlorine protection to overall protect the worker. It just depends on the specific nature of the filter and your work environment. Okay, that seems to be all the questions for now. So if you need to get in touch, feel free to contact us, info@chemsafety.co.nz, or personally sam@chemsafety.co.nz. There'll be a package that goes out with some information later on and a recording of the thing, and feel free to share it around. Thank you.